Hey everyone, welcome. And today we have here a full-scale enterprise level network where we have the classic three-tier hierarchical design. So here we have our access layer, we have the distribution layer, and we have our core layer. And on the access layer or at the access layer, our end devices are segmented using VLANs into 5 different network. So we have VLAN 10 for sales, 20 for IT, we have 30 for admin, 99 for management, and also VLAN 90 for our servers. So VLANs were used obviously for segmentation and to improve security. And our access layer is connected to our distribution switch or the distribution layer via 802.1q trunk ports. Okay, so now, since we have high level of redundancy in this network, I set up spanning tree STP, Rapid PVST plus on each of the switches in this network, just to make sure there's no loop in the network and none of our links goes down. And also for load balancing on the core switch, I set up spanning tree and I added some of the VLANs to different priorities on both core switch. So let's check that out. So let's do show spanning tree VLAN 10. So for VLAN 10, 20, and 30, I set them on high priority on this switch. And as you can see, this is within the high priority range. And then let's check VLAN 99. And yeah, as you can see here, VLAN 99 is in the lower priority range on the core switch 1. So for core switch 2, it's reversed the other way around. Okay, so for routing, we have SVIs set up on both of our layer 3 switches, and each SVI act as a gateway for the end devices in the network. So let's check that out real quick. Show IP route, or let's just do show IP. Let's check the interface, IP interface, and brief. All right, so okay, nice. So over here, we can see our SVIs. We can see the switch virtual interface for each of our VLANs, and we can see the default gateways set up on each of them. All right, so for communication across the entire network, we have OSPF running on our core layer, and that way the VLAN, the subnets of each of these VLAN is being advertised within the OSPF process. So let's just check the routes. So we have show IP route, and yeah, we should be able to see the advertised routes via OSPF. All right, so we can see on the core routers, we have the routes for each of our VLAN network being advertised, and it has this is past the advertisement stage. So this is our routing table, right? We can see that the route has already been learned by the router, and it knows okay how to route traffic across the entire network. So we can see OSPF routes here. We can see the local routes for the gigabit interfaces on the router itself. So for gigabit interface 0, 1, and 2, and we can also see a static route pointing towards the internet over here. So this static route over here just simply points to the network, to the internet. So one of the services we have running on the network is DHCP for automatic, IP and network configuration allocation to the end devices in the network. All right, so to ensure DHCP works as expected, let's plug in one of our devices here and see if it can, run the whole DORA process and get an IP address from our DHCP server. So let's do this. Switch over to DHCP. It's requesting an IP and it was successful. So we can see we successfully got an IP address from the DHCP pool set up on the router over here. All right, for connection to the internet, I set up a static default route pointing to our internet IP address over here. So let's do show IP route. And yeah, we can see our static default route pointing to the IP address of our internet router. So after setting up our static route, I redistributed it via into our OSPF, and also I set up port address translation NAT overload to save our public address. We have a very limited public IP space, so we want to make sure we are using a form of network address translation just to use one public address to access the internet. Okay, so over here we have standard access control, and this basically permits all of our internal network. And over here we have our NAT overload. So we have NAT overload, which is path. So basically what path does is we are granting permission for our internal network to share one public IP address, and the public IP address lays on gigabit interface G 002, which is over here. This is where our public address is. All right, so on our internet router over here we have a loopback address set up. So let's check that. I show IP interface, and let's make it brief. Okay, so we have our loopback address set up over here, and we will try to ping this address from our internal network, and that would show us our port address translation works. So let's try to ping this guy from over here, and let's see. Okay, nice. So we are getting a reply. So we are sending packets and we are receiving packets from the internet over here. So we are going from our internal network all the way down here to the ISP and to this external network. So as we can see, we have zero loss. That's 100% success rate, which means our path works, DHCP works, everything. In fact, everything we've configured works as expected. So let's check out our NAT translation for that. So show IP NAT, and then we have translations. Okay, and we can see, so ICMP, this was the ping packets we just sent. We can see our internal, so inside lookout, this is our internal network, which was this particular device we sent the ping from. And then we can see inside global, which is the IP address of our external interface for the router over here. And we can also see in outside local, which is the loopback address set up on the router. And yeah, outside global is still like the loopback address. All right, so that will be it for this video. Just a brief recap on the access layer. We have VLANs set up for segmentation, and then on the distribution layer we have trunking happening for inter-VLAN communication. On the core layer, on the core switch, we also have the SVIs and trunking as well running for communication across the network. And then in the core layer over here we have OSPF for route advertisement and building our and mapping routes across the network. Then on the external interface we have NAT and PAT. We have port address translation just to manage or for converting our private IP into public IP. And on the internet we have loopback setup. Also we have our DHCP running. So that will be it for this video. In the next video I have the method of procedures over here on the left, and in the next video I would go over configuring this whole network from scratch. So if you're interested in seeing that, give this video a like and subscribe, and I'll be seeing you in the next video. Thank you.